Welcome to the Center of Math's Advanced Knowledge Problem of the Week. For this week's problem, we're given a continuous real valued function f on the set x greater than or equal to 0. And we're given that the limit of f of x as x goes to infinity is equal to c. And we want to prove that the limit as x goes to infinity of the integral from 0 to x, f of t dt over x equals c. So first, we're going to consider a slightly different function. So we're going to consider a function g of x, which equals f of x minus c. Note that the limit as x goes to infinity of g of x is the limit as x goes to infinity of f of x minus c. And f of x for x greater than some m. F of x gets as close to c as we want, so this difference gets as close to 0 as we want. So this limit is equal to 0. G of x approaches 0 as x goes to infinity. So now we're going to consider this, but for g of x. So we're going to consider the absolute value of this limit, 0x g of t dt over x, as x goes to infinity. So we're going to break up our integral into two parts, 0 to some x prime to x. Note the definition limit x goes to infinity of g of x equals 0 tells us that for some x greater than m, g of x, absolute value of g of x is going to be less than epsilon, where epsilon is some real number greater than 0. So we choose our x prime so that g of x prime, and greater is all less than or equal to epsilon, less than epsilon. And then our integral from 0 to x prime is some set integer. Integral from 0 to x prime gt dt is just some number m. And the integral from x prime to x, we can approximate using the triangle inequality. This is less than the absolute value of each part. And the absolute value of this part on the right from x prime to x, we can say is going to be less than epsilon times x minus x prime. So since g of t is bounded above by absolute value of epsilon, then this whole integral is bounded above by epsilon times x minus x prime. And note that this limit on the way right, which is the absolute value of m plus the absolute value of epsilon times x minus x prime over absolute value of x, which is just x because we're going to plus infinity. Note that absolute value of m over x goes to 0 as x goes to infinity because m is set. And that the value of absolute value of epsilon times x minus x prime over x, this just goes to epsilon. So so this is bounded above by epsilon. But epsilon is just some arbitrary real number greater than 0. So therefore, this integral on the right, in fact, just is equal to 0. So because this limit equals 0, note that we can just drop the absolute value because plus minus 0 is still 0. And so it just equals to the limit of integral from 0 to x, gt dt over x, so x goes to infinity, which equals 0. Given that our function g of t goes to 0, t goes to infinity. And so now this will give us our answer. So now that we know the integral from 0 to x of g of t dt over x goes to as close as we want to 0, or just it equals 0 as x goes to infinity. So remembering that g of t is just f of t minus c. So the limit as x goes to infinity of this is equal to limit as x goes to infinity of integral of 0 to x f of t minus c dt over x, which is equal to integral of 0 to x f of t dt minus c of x over x. So the limit as x goes to infinity of the integral from 0 to x of f of t dt over x minus c equals 0. Or we can conclude from this that c equals the limit as x goes to infinity of integral 0 to x f of t dt over x. So this thing equals c. Thanks for watching. Please check out centeredamount.org, check out our blog, and follow us on Facebook and Twitter. Thank you.